Alright, this is going to be our second review on exponential and logarithmic functions. I bet you know what I'm going to say now. That's right, put your pencils down. No pencils. Okay, problem number one. Okay, to solve this equation, we're trying to find x and whatnot, you would definitely start off by dividing every side by 6. So divide both sides by 6. The 6's go away. Alright, so that's just going to leave us with log base 5 of 3x minus 70 is equal to 4. Yeah. So time to rewrite this in exponent form, starting with the base. The base is 5. Bring that down. These two parts will trade sides. So the 4 comes over here as the exponent of exponent form, and the 3x minus 70 comes over here. Okay, yeah, 5 to the 4th power, it's a pretty big number. Don't know it. 5 to the 4th power is 625. I should have known that. So I have 625 is equal to 3x minus 70. We will add 70 to both sides. Okay, so that will give us 95. Yeah, so that'll give us 695 is equal to 3x. Of course, now we divide by 3. Okay, and you can give me the nearest hundredth, so this will be 231.67. Okay, that was problem number one. Problem number two. Let me go one smaller here. When you are adding logarithms, you wind up multiplying to condense them. So I can condense this down to a single log by doing log base 2, and I'm going to do x plus 4 times x. Okay, now of course when you multiply, you're going to wind up distributing. So this is going to be log base 2 of x squared plus 4x. Alright, now it's time to rewrite this in exponent form like we did the last problem. Start with the base. The base is 2, just bring that straight down. Okay, and these two guys are going to trade sides, so the 5 is going to come over here and become the 5th power. Meanwhile, this binomial is going to come to the right, x squared plus 4x. 2 to the 5th power is 32. You can find that on your chart if you need to. Okay, I'm noticing that I have two different kinds of x's. So I can't just get x by itself. So this must be the type where I get everything on one side with a 0 over here and factor. Okay, so now I've got 0. So this is 0 equals x squared plus 4x minus 32. And let's see if we can factor it. X squared could only be x times x. 32. Alright, that could be a bunch of things, but let's see. One thing it could be is 4 times 9. I'm sorry, 4 times 8 is 32. Okay, and there's other stuff, but let's start with this. Okay, let's try the 4 times 8. Now, the inner and the outer have to make the middle. Inner, we have 4x. Outer, we have 8x. We need a positive 4 middle. We can get that if we have a negative 4 and a positive 8. That would make positive 4. So there's your negative 4 and there's your positive 8. So in your face factoring. Let me just get this out of the way for a second. So, but we're not done, of course. We need to find out what x actually equals. So we're going to set the two factors equal to 0. X minus 4 equals 0, and x plus 8 equals 0. Adding 4 to both sides gives us x equals 4. Subtracting 8 from both sides gives us x equals negative 8. Alright, then we have to look back and make sure that neither of these solutions are extraneous. 4. The main thing you have to watch out for is if you plug it in, you can't get a negative number, or 0 for that matter. You can't take the log of a negative number, or 0. So, if I put in 4 here, that gives me 8, that's fine. If I put in 4 here, I just get 4. And that's also fine. So that's not breaking any laws. On the other hand, if I put in negative 8, that's going to give me negative 4 here, and right here that's going to give me negative 8. So this is going to be extraneous. That's a no-go. So cross it out, write extraneous. Okay, so 4 is my only answer. So please understand, if this were a test, okay, and you know, I gave you an answer line somewhere, you're not going to put anything about this extraneous value on the answer line. The only thing I would want to see on the answer line is x equals 4. That's it. Nothing else. I expect to see this in your work. Okay, so that's number 2. Let's find number 3. On this one we have logs on both sides that are the same, so we can drop those out, and so we can go to 8x minus 9 is equal to 2x plus 3. So getting these x's together, you know, subtract 2x from both sides, so that'll give us 6x minus 9 is equal to 3. Then you're going to want to add 9 on both sides, so that'll be 6x equals 12, and then we will divide both sides by 6, and we get x equals 2. Alright, make sure that's not extraneous. 8 times 2 is 16 minus 9, that's fine. 2 times 2 is 4. And plus 3 is 7, so that's fine. Nothing wrong there. So number 4. Okay, we have subtraction, and we want to condense these. Subtraction condenses down to division. So when I make one log out of this, I'm going to take this and divide by this. So I will have x squared plus 12 over 3. Alright, and I've still got this 4 over here. Okay, now I have to solve this. It's time to rewrite this in exponent form like we often do, starting with the base. Always start with the base. I'll pull that 2 straight down. Now meanwhile, these two things trade sides. So the 4 comes over here and becomes the power. The fraction comes over here. So I've got x squared plus 12 over 3. 2 to the 4th power is 16. Alright, so I've got 16 is equal to x squared plus 12 over 3. Time to multiply by the denominator. Alright, so those go away. 3 times 16 is 48. Alright, so I've got 48 is equal to x squared plus 12. Notice I've only got one x here. I mean, I've got x squared. as opposed to the other problem that we did where I had x squared and x, so I couldn't get x by itself, because if I got x squared by itself, I'd have 4x on the other side and x wouldn't be by itself. But since on this problem I only have one type of x, I can just get it by itself and take the square root. So that's what I'm doing. So subtract 12 from both sides. So that's going to be 36. And let's take the square root of both sides. Please don't forget, when you take the square root of both sides, the solution will be positive or negative. If you only put 6, you will only get half credit, because that's only half of the solutions. Okay, so that's x is equal to plus or minus 6. So please understand that means x equals 6 is like one answer, and x equals negative 6 is another answer. Now let's look back and make sure neither one of these are extraneous. This first, the 6. If I have x squared plus 9, well, plus 12, well, that's 36 plus 12, that's 48. That's fine, nothing wrong there. What about the negative 6? Negatives are scary. But negative 6 squared is still 36, so it's still 48. So even the negative one is fine. So we just have these two solutions. Keep them both. Alright, condensing. So in the end we will have one log instead of two. Part of condensing is taking these coefficients and putting them up as powers. Okay, that includes this 1/2. Okay, so on that first step then I will have log base 5 of x to the third power minus log base 5 of y to the 1/2 power. Okay, now please understand that 1/2 power is the same thing as the square root. Okay, we were to have memorized that. 1/2 power is the square root. Now, when you are subtracting logs, when they condense, subtraction becomes division, as we saw a moment ago. So this will be log base 5, but we have to do the left divided by the right to make it one log. So I will have x to the third power over the square root of y. And that's it. That's how this would condense. Okay, number 7. Which of the following is not correct? Well, let's see. For A, first thing we would do, obviously we're condensing here, okay? So we're seeing if the left equals the right or not. And we're looking for the one that's wrong. If we put the 5 up as the power, okay, if we moved it 4 to the 5th power, looking at the table, 4 to the 5th power is 1024. Oh look, 1024, so that one's correct. So that's not the answer. A moment ago we discussed that when we add two logs, they condense down to multiplication. So this would condense down to log base 3 of 6 times 5, and 6 times 5 is 30. So that one's correct. Same thing here when you're adding two logs, so when you're condensing, it condenses down to multiplication. So this would be like 5 times 12, which is 60. So that one's correct. Okay, when you are doing a subtraction problem, you must create a division problem when you condense. So this will condense down to log base 5 of 15 over 3. You have to divide. Okay, but this gives you log base 5 of 5, because 15 divided by 3 is 5. Now, the value of this you should be able to do in your head as you ask yourself 5 to the what power is 5? And that is 1. 5 to the 1 power is 5. So the value of this is 1. And that's what we have, so this one is correct. That means E must be the answer. And of course, when you are subtracting 2 logs, you condense them by doing division. So this should be 6 over 5, which does not simplify anymore. And here they have 1. So that is clearly false. Obviously, the mistake that they're illustrating is thinking that you would just subtract 6 minus 5 and get 1. It's not how it works. It becomes division. So that's why E is incorrect, and therefore E is your answer. Genius. Okay, I feel like we've already done this 50 times, but we were condensing. This coefficient is going to become the power as we condense. So this will be log x to the 5th power plus log 6. And once again, when you're adding 2 logs, you condense by making it into a multiplication problem. So we'll be multiplying these 2 things. And traditionally we would go 6x to the 5th power instead of x to the 5th times 6. So that's it for number 8. Alright, is number 9 down here? It sure is. Alright, so one more of these expand, condense things. So this one we're expanding. Now check it out. There are 3 terms here. Well, there's 3 factors, and they will lead to 3 terms when we expand. Okay? There are 2 terms in the numerator and 1 term in the coming from the denominator. The 2 terms that come from the numerator will be positive. Alright? Factors in the numerator always give you a positive term in your expansion. Anything in the denominator will be a negative term. So we will have natural log n squared, okay, positive, alright, and then plus natural log p to the 4th power. So these are both positive, they are from the numerator. But then we will have minus natural log r to the 9th power. Alright, it was in the denominator, so therefore we made it negative. Finally, any exponents, when we're expanding, they go out front. Okay, so that's why the final answer is going to be 2 times natural log of n plus 4 natural log of p minus 9 natural log of r. And that's number 9. Now, for the next 4 problems, we are finding the inverse of each. Now, remember, finding the inverse, first of all, this is basically y. It has 2 main steps. We switch x and y, and then we solve for y. So here I am switching x and y. So that's going to give me x equals natural log 9y. Now I need to solve for y. So I'm going to do that by rewriting this in exponent form. I'm going to need the base. So please understand that natural log is invisible base e. So we're going to rewrite this in exponent form. Start with your base. So there's my base. Now everything else is going to change sides. Now we're going to exponent form, not log form. So there will be no more log. There will be no ln. The 9y is going to come over here to the left. The x is going to come over here and become the exponent. So trying to get y by itself, we will divide both sides by 9. Okay. So that is going to give me y equals e to the x power over 9. Wait, let me not put a box around that yet. Let's replace the y. We started off with an f, so let's put the f back, but we will make it the inverse by calling it, put it with this -1. Now it's f inverse. Okay, that's number 10. Number 11. So this is basically y. So the two main steps of finding the inverse are switch x and y and then solve for y. Do you have a pencil in your hand? Did you sneak a pencil while I wasn't looking? Shame on you. I'm looking at you now, right through this telephone/computer screen. Yeah. Put it down and be ashamed. Be very ashamed. We switch x and y. So this will become x equals log base 11 y plus 7. The nerve of you. I still can't get over how you were trying to copy off me. Man, you know you don't learn that way. Come on, people. So now we have to solve for y. Guess what? Exponent form. Starting with the base 11, 11. Okay, bring that down. Now the x and the y plus 7 are going to change sides. So the y plus 7 is going to jump over here. The x is going to come over here and become the exponent. Trying to get y by itself, so you know, -7. So that's going to give me y equals 11 to the x power minus 7. This is basically the answer, but let's put that j back in there. Okay, so we will have j of x, and we will make it the inverse by putting the little -1 on it. That means j inverse. Okay, that's number 11. Number 12. Alright, this is basically y. So we need to switch x and y and then solve for y. So this will become x equals 5 times 8 to the y power minus 7. Now, before we do any changing of the forms, we need to get the base and power part, the yellow part, by itself. Am I going to divide by 5 first, or am I going to add 7 first? That's right, clearly I'm going to add 7. You are so smart. Smart and good looking? Your mother must be very proud. So that's going to be x plus 7 is equal to 5 times 8 to the y power. Now we will divide by 5. Okay, that is great. So that is going to give us x plus 7 over 5 is equal to 8 to the y power. Alright, now that this yellow part is by itself, this is when we rewrite it in the other form. Now this is exponent form already, so the thing that we must need is log form. Always start with the base. The base is 8, but in log form we say log base 8, and we put it low. Still, this stuff is going to trade sides. So the y is going to come over here, and this whole fraction is going to come over here. So I'll have x plus 7 over 5. So this is the answer, but this is supposed to be a g function, so let's put the g back in. Okay, so we will have g of x, and we will make the inverse by putting a little -1 on it. So that is the inverse function. Okay. See, do we have any other logs I have to yell at you about? See, exponent form, exponent form. Alright, maybe the next one is where I'll yell at you. Okay, I'll wait and yell at you about number 13. What is he going to yell at us for? Just wait and see. You'll deserve it. Wait and see. So this h is like a y. There's 2 steps in this process. Well, 3 if you count the step where you put down your pencil. Yeah, didn't see that coming, did you? You switch x and y, and then you solve for y. So this will be x equals natural log y minus 9 plus 5. Alright, I switched my x and my y. Now I have to solve for y. So first I subtract 5 from both sides. So now I'll have x minus 5 is equal to natural log of y minus 9. Remember that natural log is an invisible base e. Okay, so it's time to rewrite this in exponent form. Okay, starting with the base e. There it is. Okay, now the x minus 5 and the y minus 9, they're going to trade sides. So the y minus 9 is going to come out here. The x minus 5 is going to come over here, but it's going to be the power. X minus 5. Okay, then we need to add that 9 to both sides. So we are going to get y equals e to the x minus 5 power plus 9. Okay, now remember this was an h function, so let's put the h back in. Alright, so we will write an h function, and we'll put a little minus 1 in there to make it the inverse. So this is h inverse equals all this. So that is the answer to that. Okay, so that was number 13. Alright, looks like we're down to the last 2 problems, 14 and 15. Easy peasy lemon squeezy, my people. Okay, look at this symbol. Look at it real close. Are you looking at it? Are you thinking above or below? Say it out loud. No one's going to think you're crazy. I hope you said above. Okay? Because this is a greater than symbol. Log base 2 of x is greater than 5. And greater than means above. So that's important because we want the part of this graph that is above 5. So this red line here represents 5. Okay, it's a height of 5. So obviously this is the part of the graph that is above 5, you know, because this is clearly below. So that's above 5. Now, when I translate this into a number line graph, okay, because I'm strictly looking at the x values for my solutions. First of all, I need the critical value, where it all starts being above the line. And the critical value is right here. Now, should I be looking at the 32 or the 5? Yeah, the 32 is what we are talking about, the x value. Alright, because we're making a number line and it's like the x-axis. So 32 is the critical value. Am I going to put an open circle or a closed circle? I'm going to put an open circle. If this had been greater than or equal to, I would have filled it in to show that equals 5 will include the point, the end point. But if we have to stay greater than, strictly above, then we can't include the point where it's equal to 5. So we leave it out by making it an open circle. So the only thing that's left is, are we going to find our solutions to the left of this critical value, or do our solutions begin to the right of this critical value? Well, just look at what we highlighted when we talked about the part of the graph that was above. Okay, is this part of the graph on the left or the right of our critical value 32? Clearly it is to the right. Okay, just look at your highlighting. So that's why we will draw our solutions going to the right. Okay, and we must write this in interval notation as they requested. Okay, so recreating this solution set in interval notation, I'm going from 32 to infinity. Alright, so I put 32 to infinity like that. Notice I put a round parenthesis right here. For the same reason I have an open circle right here. A round parenthesis means the 32 itself is not included. Alright, we have to stay above 5, so not equal to 5, so we leave out the endpoint with a round parenthesis. So there you go. That's number 14. Now let me just mention, if this had been less than, okay, and obviously had it been less than, we would have been looking below, so we would have wanted the left side of the graph. But please understand, if we were going to the left, we would not go to negative infinity. Please remember that for log functions, this right here, the y-axis, is an asymptote. Wow, that's big. Deal with it. I don't care. Okay, that's the asymptote. So the graph doesn't go to negative infinity. Log functions don't go to negative infinity. It stops here at 0. In fact, it doesn't quite reach 0. So if it had been less than, then okay, this is no longer working for me. If it had been less than, then we would have our interval would have been from 0 to 32. Okay, like that. And again, we'd use round on the 0 even, because we don't reach the 0. It's the asymptote. Okay, and when you did your number line, okay, and again, this is hypothetical, like if it had been less than, your number line would have been like this, okay, instead of over here. Okay, but that's not what happened, so forget about it. Alright, last one. Looking at this symbol, am I thinking above or below right now? Hopefully you are thinking below. No, I'm about to spell it wrong. Below. Alright, because this is less than or equal to, so that should be below 8. Alright, so this red line represents 8. So below 8 would be this part of the graph that I'm highlighting now. Alright, that's everything that's below 8. So when we get ready to make our number line version of our solutions, we will use the critical value that we're given. Okay, right here the x value is -3/4, so we will just use that because that's where the graph started being below the line. Now am I going to use an open circle or a closed circle? Alright, this will be a closed circle because it's less than or equal to. So closed circle shows that we include the endpoint. So all that's left is, will the solutions be to the left or will they be to the right? And you can look right on this graph. See the part that we highlighted? Alright, the part that's below. Does this yellow part go to the left of the critical value here, or does it go to the right of the critical value? Clearly this below part is to the right. Okay, you see it's going to the right. So we will make our number line going to the right as well. And there are no asymptotes to block us off here, so whether it's to the right or to the left, it will be to infinity and beyond. So we'll write this as an interval notation now. So this is going to be -3/4 to infinity. Now, will I use a round parenthesis or a square bracket on my negative 3/4? Square. Okay, for the same reason we did a closed circle. It's or equal to, a square bracket shows that we include the endpoint of negative 3/4 as one of our solutions. Infinities always get the round. Okay, so that would be the interval notation of the solution set. Alright, that's the end of this lesson. Please remember that this is only half of a review. The other half will be on the next video, which will be called Day 9 HW. Alright, Test D Part 2. I'll see you on that next video.